Yesterday we switched gears from our focus that we've had for the last several days on factored form into going on standard form. Today we're going to take that finding the vertex and put it into an effort to graph these. So our first example is y equals x squared plus 8x plus 8. And the first step is going to be to determine that axis of symmetry. And if you remember from yesterday, that finding that axis of symmetry, we're going to take the opposite of b over to a. In our case, b is 8 and a is 1. So our x equals the opposite of b, opposite of 8 is negative 8, over 2 times our a, which is 1. So we have negative 8 over 2, which is negative 4. So if we rewrite this, we've got x equals negative 4. Our next step then is going to be to determine that vertex, which remember this part isn't any different than our process was for finding the vertex when it came to factored form. We're now going to take this x equals negative 4 and we're going to put it into this equation. So we have y equals x squared, which is negative 4 squared, plus 8 times negative 4 plus 8. Negative 4 squared is 16. 8 times negative 4 is negative 32. We have our plus 8. Negative 16 minus 32 is negative 16 plus 8, which equals negative 8, which means our vertex is negative 4, negative 8. Our third step is going to be to determine that y-intercept. This is the piece that when we were using factored form, a lot of you guys got in the mindset of vertex and completely forgot about your y-intercept. Remember, y-intercept means it's the point where it crosses the y-axis, so therefore x is 0. So we're going to put 0 in for x. We get y equals 0 squared plus 8 times 0 plus 8. 0 squared is 0. 8 times 0 is 0. Plus 8 gives us 8. Therefore, our y-intercept is 0, 8. Finally, once we have that part, we're going to plot and connect all of our points. So the first thing that I want to do is I want to draw in that axis of symmetry. X equals negative 4. So I'm going to draw a dotted line through that spot so that way I know where my axis of symmetry is. Then I want to plot my points. Negative 4, negative 8. So I go down 1, 2, 3, 4, 5, 6, 7, 8. And then I have a y-intercept of 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I can start by mirroring this point here over 4 on the other side of the axis of symmetry. And then remember, we can add in a step 5 here. We need 5 points. So I'm going to make a t-table. And so if I do that, I'm going to decide where to pick my values. I see that between here and here, I should pick for my other value because those are between my intercept and my vertex. Likewise, I should pick between here and here because that's between the mirror of my y-intercept and my vertex. I like to do halfway, so I'm going to do negative 2 and negative 6. And it really doesn't matter as long as you pick them on equal sides of the vertex. If you want to go one away from the vertex or the axis of symmetry, that is fine. But either way, if you go equal sides, then you know that you're going to have the same y values, so you only really have to check one. I'm going to check negative 2 because it's smaller, therefore making my life a little bit easier. So I'm going to do y equals negative 2 squared plus 8 times negative 2 plus 8. Negative 2 squared is 4. 8 times negative 2 is negative 16 plus 8. 4 minus 16 is negative 12 plus 8 is negative 4. So I know that both of these values are negative 4. So now I have 2 points that I can graph. -2, -4, and -6, -4. So now I have my 5 points. Make my nice curve, putting my arrowheads on the end, and I've got my point. What I want you to do now is to go ahead and give this problem a shot. Find your points, enter your vertex, your y-intercept, and your 2 additional points into Edpuzzle, and then go ahead and graph it, and then you can press play when you're done so you can check your work. Go ahead and try this next example. We're going to start off with my axis of symmetry, and to do so we're going to take x equals the opposite of b, so -6, over 2a, which is 2 times -1, -6 over -2, which is +3. So my axis of symmetry is x equals 3. Then I move on to my vertex. And my vertex, I'm going to plug that point in. I get y equals the negative of 3 squared plus 6 times 3 minus 1. 3 squared is 9, take the negative of it, so it's -9. 6 times 3 is 18 minus 1. -9 plus 18 is +9 minus 1 is 8, making my vertex 3, 8. Finally, moving on to the y-intercept, and I get, put in 0 for x, I get y equals the negative of 0 squared plus 6 times 0 minus 1. If you haven't noticed yet, the first 2 terms will always cancel out because of that 0, therefore making y equal to -1, and my y-intercept is 0, -1. I can then go ahead and plot my points. I'm going to make my axis of symmetry at x equals 3. And then I can plot my vertex at 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then my y-intercept at 0, -1. I can mirror that image. And then I need to make my t-table. In my case here, I see that I want to be between here and here and here and here. I'm going to choose 1 away from the vertex, so I'm going to choose here and here, which is 2 and 4. 1 away from the vertex, or the axis of symmetry. That makes it a lot easier to work with. So if I put in 2 into my equation, I get y equals the negative of 2 squared plus 6 times 2 minus 1. 2 squared is 4, the negative of it is -4. 6 times 2 is 12, minus 1. -4 plus 12 is 8, minus 1 is 7. So then I can plot my points of 2, 7, 1, 2, 3, 4, 5, 6, 7, and 4, 7. And I can make my curve, and I am done. The next one is a little bit trickier just because we do have now a coefficient out front. So let's go ahead and give this a shot, starting with our axis of symmetry. So we have the opposite of b, which happens to be -12, so the opposite is 12, over 2a, so 2 times -3, 12 over -6. 12 divided by -6 is -2, making my axis of symmetry x equals -2. As for our vertex, you have here y equals -3 times -2 squared minus 12 times -2 minus 8. -2 squared is 4. 4 times -3 is -12. -12 times -2 is +24 minus 8. -12 plus 24 is 12 minus 8 is 4, making our vertex -2, 4. And then finally our y-intercept, put in 0 for x, we have y equals -3 times 0 squared minus 12 times 0 minus 8. So y equals -8 because these first two terms turn to 0, making my y-intercept 0, -8. So now I'll go ahead putting my axis of symmetry at x equals -2. Then I have a vertex at -2, 4, and a y-intercept at 0, -8. Mirror that point across, and then I'm going to choose, I have to choose points between the axis of symmetry and my two outer points. So that means when I make my t-table, I'm going to choose -1 and -3. When I put in -1, I have y equals -3 times -1 squared minus 12 times -1 minus 8. -1 squared is 1 times -3 is -3. -12 times -1 is +12 minus 8. -3 plus 12 is 9, minus 8 is 1. So now I have my two other points, -1, 1, and -3, 1. And then I can draw my curve, put in my arrowheads, and I will be done with that problem. I want you now to give D a shot. As always, enter your information that you can into Edpuzzle, and then you can check your work to see if it's correct. Starting with the axis of symmetry, we're going to put in x equals the opposite of b, so +2 over 2a, which is 1/2. 2 times 1/2 is 1. 2 over 1 is equal to 2. My axis of symmetry is x equals 2. For my vertex, put that value in, so we have 1/2 times 2 squared minus 2 times 2 plus 9. 2 squared is 4, half of 4 is 2. 2 times 2 is 4, so minus 4 plus 9. 2 times two minus 4 is -2 plus 9 is equal to 7. My vertex then is 2, 7. For my y-intercept, we put in 0 for x, so y equals 1/2 times 0 squared plus, minus 2 times 0 plus 9. That means that y equals 9, and my y-intercept is 0, 9. Went ahead to graph this. I have my axis of symmetry at x equals 2. I have points at 2, 7, and 0, 9. Mirror that over. Notice this one goes off the graph. In this particular case, I would be okay with you having just 3 points, only because it is going to extend off the graph, although you could do 1 and 3. However, you're going to get into fractional values, as you can see, so we will leave it at that. Your job now is to go ahead and graph this U-try problem. Bring your questions with you to class tomorrow.